for the students? Were they helpful, or were they upset?
They were helpful.
Okay. It would be great for me to connect into the meeting and see what is going on completely, but it was not possible. It was a time of waiting and taking over.
Oh, that like employment thing that I'm trying to fill out, like the middle page with all like the check boxes and stuff. I would have to like print that out, I guess, to do it. Like I can't do that online. You just want me to like scan you a copy or give you like a hard copy? Or?
I don't care much. Hopefully the bureaucrats will be flexible. Yeah, well respected administrative assistant. So, toys. I do not have any time to prepare new toys every time, so some of you have already seen them. And if you are doing molecules, you're probably ahead of me in skills of building them. So it's only about solids. So this is crystallized silicon structure. So not of you will get toys directly, but you can share. So these titanium dioxide, a little bigger than the one the structure. And in real life, electrons do oxygen. And this is perfect. So just play with them to entertain yourself. And if you see a model of a solid, you can, well, as always with toys, you can break it. But if you do not have enough steam to break it, you can just imaginally assume that you cut and remove several atoms so that you make an imaginary plane and remove everything above the plane and keep everything below. And there are different ways to do this Gedanken experiment. So you, if you select different planes, you have different patterns of surface atoms. And right now, what both London and Daniel are doing, it is the simplest surface of this material. One can cut at different angles as well. And one can also cut the surface at the end of unit cell or in the middle of unit cell, and then it will be different pattern as well. So if you explore the materials, you can observe that some properties do depend on it. You're not doing like having living peroxide, which is just floating around. Mm-hmm. So I will not show in detail and configuration direction. Maybe I'll do it on the weekend and share slides. But our primary goal is to complete written reports and oral presentation, right? No one objects on presenting in a week from now or Thursday. No objections one, no objections two, no objections three. Everyone's supported. Okay, great. Please make your best effort to bring written reports 2 days before oral presentation. Typically, in everyday practice, it is so much easier to present than oral presentation to write up. We are doing otherwise. I know it is complicated. It's much easier to mumble something than write follow-up notes. What into written reports? Please give a little sign if you already have an idea how you will compose it. So, please give signs if you are panicking and do not know if you have data, but okay. And if you kind of in between, you know general ideas, but you do not know how to arrange it logically in each other. Okay. So I want to believe, although I know it is not true, that you have completed all your calculations. I hear that's a lot. So then part of your brain will keep thinking of completing the work, and part of your brain will think how to accomplish the actual writing, how to put together and logic very much, which is a very big challenge for some people. So skills change very much, and there is a group of people who are happy to do like 1,000 times more calculations, but are scared to write one page. So it is different skill, and it doesn't really connect to your productivity as researcher in scientific sense, but you cannot survive without writing reports and papers, right? I'm a good writer, but I'm constantly thinking about it and trying to find the secret key how to do it quick and optimal and invest as least time as possible into this. You know this, right? So we summarize the course. I think we already did it a week ago. On Tuesday, we will do reviews, and on next Thursday there will be presentations, and then whoever doesn't want to see me will not see me. And one can continue this research on your own for your primary research group or for your time. It's a long. Yes, it's a long one. So there are two things that I do want to cover. They will be brief, and even this little technical issue shouldn't prevent us from completing everything in time and very efficient. So there will be two things, one of which is set of figures and tables. So a reader starts reading paper from the beginning, but a writer may start from the end. And if it is a technical writing, there is no reason to write anything if you do not have factual data. So you first collect all data and make figures and tables, and only then start writing. So the first thing to do is to arrange your manager. Can you just check that? Okay. For some period it was muted. Check that it is not muted. Okay, it's fine now. So your factual data. Suppose that you have completed all of your research. Last time we did discuss what are the goal of research and how to arrange running of your jobs. What is the sequence and what to look for, right? And if you were not on the connection, it was recorded. So basically, there were two protocols: one for hybrid systems and B for charge transfer, and another for chemical reactions. And you do originally you check properties at equilibrium geometry, and then you do perturbation by molecular dynamics, which is prepared either by thermal heating or by set up collisions with initial velocities, and then you compare the product configuration for electronic properties. And if you do have a hybrid system, then your protocol changes a little bit because you may want to check the compound A, compound B independently, and then putting together and see how they interfere to each other. Especially for this interface, I think it is very beneficial and healthy to explore orbitals to see other charge transfer states. This is very creative activity. There are no rules. So those are just ideas and suggestions, and everyone will do his or her own way. So I just imagine myself on your place and how I would do it. So minimal effort, and do not be scared of figure number 7. Sometimes you do less figures, less pages. Like the shorter the paper, the easier it is to grade. Brevity is a sister of talent. So do not hesitate if you are brief. But sometimes you already have material that you want to present, and you have a challenge how to arrange it logically. So first you just show geometry, and because a reader may not be aware of chemical nomenclature, or if you do not show geometry, if you do not tell what you are researching, there is no reason to look forward. So geometry is needed always. If you want to identify fragments, you may even do schematic diagram. If your model is big, you can just do circle and triangle and tell this is component A and B, and they put together something crazy, but that will appeal to intuitive understanding of your reader. One of possible things to explore was to look for total energy in different configurations: anions, cations, spins, charge. You can just put it as a table. Okay. Nothing is mandatory, just showing possible way. And then in the main text, you just, instead of writing long discussion, you can see trends from table 1. Most interesting is the level 1. We all know how to do density states, right? You shouldn't hesitate. Looking at density states, you do see whether your system is a metal conductor or insulator. If it is a radical, it also has some features of frontier orbitals coming close to each other. If it is non-covered transparent media, non-reactive, it will be very wide gap with in UV. So just looking on the density states, you can learn a lot, and you can tell a lot to whoever reads your. Well, if if your material is highly magnetic, if it is unpaired spins, I would say that for some of the projects it is optional, but if you have single transition metal ion, this could be very reasonable. If you have metal cluster that is most stable at cation +5, you may decide to keep this. And again, another thing that I just want to suggest, even if you are bright, efficient, and productive, and you complete all research project in a day or in a week, scientists, there are no spherical, there is no spherical scientist in a vacuum. Scientists talk to each other. Someone is reading what you are writing. And even if your research results seem very clear and straightforward, for most of the readers, it will be a little intellectual challenge to understand what you mean and how it was logically arranged. So, same as you were practicing building a tree of directories and naming them logically. And maybe some of you were already lost in your own directories. Similar thing with figures. You don't do like 100 figures one panel. You merge them together. One figure, like 4 panels. And if you have like fragment A, fragment B, and hybrid, you can make multi-panel figure called A, B, and maybe C instead of A plus B. And then keep rolling on the same 3 panels for like density, spectra, orbitals, so that the same logical pattern repeats as you go forward. You don't necessarily need to repeat exactly A, B, C, but keep the same pattern if it is possible. It makes much easier for a reader. And on coming Tuesday, until Tuesday, you are writers. On Tuesday, you will be readers, and you enjoy reading of your classmates. So help each other and make it simple logic. Keep pattern. Same for spectrum. Orbitals. Even for humble, small systems, one can build like hundreds of orbitals, and it is not possible to show it in any paper. So you need to identify only the most representative. Which orbitals make sense to show? You have seen in your previous lab and other research that the amount of orbitals can be exceedingly high, right? So if you have no idea which orbitals to show, you just show homology if you have no idea what your system is doing. But if you are trying to analyze, there are 2 types of orbitals to focus. Those that give highest oscillator strength and those that show charge transfer character. Okay? Because it is, they will be involved in most interesting processes. During your presentations, you will be showing movies, even if you do not know about it. And last Wednesday before your presentations, I have solid intentions to be in the QVV 132 to help everyone to make the movies. But each presentation should have at least one movie because it is the only way to show molecular dynamics. If you want to tell about the dynamics in the writing, it is a challenge. You cannot show 1,000 snapshots or even 100 snapshots. So you can select only maybe a couple of them. Initial, final, and maybe one or two intermediates. Right? And you can put them into a figure. It's labeled by arrows, like which atom moved where and which reaction you assume it corresponds to. This is for absent Christian and for present Russell and for present Ray. If you're doing actual chemical reaction and you are confident that you got what your intuition and experimental experience prompts you, you still want to quantify your analysis of reaction, to go from qualitative images to quantitative characteristics. And there are several ways to characterize the reactions and dynamics. So first, you can do a snapshot of potential energy as function of time, which is done by grep T equals from Ozikar. We did it. Like column number 3 will be total, will be temperature, and then apostrophe T equals cos Z bigger into some file. And the file will contain of columns where one column will be text, which observer, the second column will be third will be text, fourth numerical value, or maybe like like this. Yes.
On that, I have a question. What is, or how is the free energy, the F, the free energy calculated, and how is it different from E and E0?
In order to answer this question, we need to be partitioned in PChem2 and statistical mechanics, which is different from, and thermodynamics. Right? So you just look for definitions. There are like entropic terms for this thermodynamic potentials. The internal energy, free energy, Gibbs energy, they have different terms added. And there is no big problem to incorporate it into the code, just by equation, not by computing the ensemble in size.
But I didn't see potential energy, only kinetic potential and E now.
There is a potential. I will not tell you, not because of bad intentions, just because I don't remember which column is potential energy, but if you plot each of those, and you plot kinetic energy, and another column will show the same trend with opposite sign. So that two of the columns will be added to a constant upon addition. The one that goes in counterphase to kinetic energy is potential. Okay. Another, and it will be enough, especially in the given time. If you are really energetic, excited, and you have nothing to do until the 3 a.m., you can also write the parse the interatomic distances and explore how the distance between like catalytic center and center of mass, or most closest approaching atom of the reactant group, the distance as function of time, and see how they approach and then dissolve or stay. Do not bother if you're busy, but it is an option. Any questions about arranging data? I do have a question to myself. So basically, this is model, this is dynamics, and this is characterization. How do I arrange and how do I label the characterization before and after thermal treatment? So an option is that I can do G, and first three will correspond to ground, to equilibrium geometry, and next three will correspond to perturbed geometry. So in each characteristics there will be, let's say, one panel corresponding to electronic structure characteristics after thermal treatment. Okay. At least it is clear. Now, scroll up, and I'm going to entertain you. So, suppose you, now assumptions are becoming stronger and rougher. So, 20 minutes ago, I assumed that everyone has completed all calculations. Now I assume that everyone has completed calculations, figures, and tables. What next? If you meet a stranger in a store or in a line to board to the airplane or whatever, some people will ask you, what are you doing and who needs it? So I am deriving equation. Who pays for it? Government. Okay, you're pulling my taxes to do something that no one needs. So you may prepare yourself to answer to questions of such people and to write introductions to your papers. So this is, of course, oversimplified cartoon more for entertainment, but there is maybe a little grain of truth in this. So when you're doing science, you are doing publications, maybe patents, and through industry it gives back some useful things to people who later pay taxes and support science. Right? So, and you may clearly explain what you give to rest of the people. An indirect way is that there is a development of workforce who do these nice things, and there is a education that also may not produce anything material, but just help people to general literacy. And there are additional things for like medical applications. They are also connected through the database applications and something technology. When you write the introduction to your mini paper, you don't need to. Brevity is a sister of talent. You don't need to write 10 pages introduction. It can be 1 or 2 sentences, but you can share your own vision. Who benefits of the application of the properties that you are researching? Like the project that Alice is doing has very clear benefit. Like she is telling whether the chemical environment will keep cell alive or make it dead. Clear. Life or death? Simple motivation. you can do something similar, like solar energy program for free. So in our today society, we have a simple flowchart for technical writing. You do introduction, methodology, results, and conclusions. Right? 4 pages. Your written reports. It doesn't mean that you need to have 1-page introduction. Rough connection, how to connect your 7 figures, and maybe there will be a little space for text. So this is what we all are doing. And I'm going to chat a little bit about this protocol and flowchart, and then tell alternative pathways So the reader will read what you write much quicker than you write. And the reader typically reads from beginning to the end. Writer is not obliged to use. When you do your research, you get some answers to some questions. And when you do research, since you are, all scientists are knights who fight with absence of knowledge, this like fog of war if you play computer games. And when you start research, you do not know what you will get. Often, if you know what you will get, you are very well organized strategic director of an institute. Sometimes you don't know what it is, but at the time when research is complete, you have some answers. By style of human thinking, it is much more healthier to pose a question first and get an answer second. So design a question that you're getting an answer to. It will be much easier to read and understand what you mean. If you can pose a question before you start research, it is good. It is best. But it is not always the truth. So design question, and you can even declare hypothetical answer. So right now we are reaching very far opportunities of grant proposal writing activities that some of you may experience soon in trying to apply for GRFP stipend from National Science Foundation to graduate students. So these ideas are very well appreciated by NSF, the federal agency. So if you pose a question and then you state hypothetical answer, and then you form your writing as set of practical steps to prove your hypothesis right or wrong. So you can, it is not what we do if we are just enchanted by research. Sometimes we just curious, do something and then find something. But when you explain, this is better, if you can. Methods. Idea of methods is to make an impression that you do not hide any technical secrets and you allow all your readers to reproduce your results. If you really can help readers to reproduce results, it's even better. But HPC clusters, NERSC, or Dakota cluster solves equations. You know which ones, right? So, let's see. If your reader will be a theorist, even not a computational chemist, then the only question will be which equations are being solved. So your results represent solution of which question, of which equation. So do not hesitate to write equations. Also, if you do some, if you show some observable, do not hesitate to put an equation. That, like if you have distance between two atoms, right? Square root of position x1 minus x2 squared, y2 minus y2 squared, z2 minus z2 squared, where x, y, and z depend on time. This is not a big discovery, but it helps reader to see the logic. And unless you teach simple arithmetic to reader, most of readers do not object simple thing. If you tell something simple, you may fear it and think that reader will tell, they teach me what I already know. I decline this. No, reader will think, oh, I know this. Good paper. So it is fine to give some introductory things. Later, in the iteration, in the improvement of your writing, you can exclude them if you see that they are unnecessary. But when you build up a skeleton, it's better to be give definitions and be precise and give sense. Also, contact me if you need some help test methods. I do have templates that I will be happy to share. You can adjust based on the needs of your actual research, but your task here was not to derive equation. Your task was to make actual research of materials. So it's fine to use some sources. Good. Well, in oversimplified way, results is just look at figure 1. It shows structure. Look at figure 2. It shows dose. Look at figure 3. It shows absorption. Result section is done. Well, you understand that it is an exaggeration. You can put a little bit more and explain what reader observes there. But if you are under time pressure, the results is very straightforward logic. As soon as you have figures, data done, and figures done, you just glance through them. And in the discussion, you just interpret what you see and why. And in conclusions, you tell whether your results support your hypothetical answer and convince the reader that it is valuable and trustable results and they are extremely beneficial for the benefits of the human.
What if you're not sure if they're valuable and trustable?
Then, if you're not sure about something, you add the word potential in front. Good. Do not hesitate to put references. The best way, well, if you practice LATIC, it's excellent, above excellent. But if you're not exposed to LATIC by today, and you practice Microsoft Word, the best way to put references is so-called end node. So again, contact me privately if you don't have access to it. Basically, it is a add-on stuff that cooperates with Microsoft Word. When you read papers online, you download the record, and then you just navigate to place in the text where you want to say something, you click, and then they automatically are numbered. If number of references is like 5 or 10, it doesn't matter, and type in everything. But if it is a little above, this automatic numbering is useful.
The program Mendeley does the same thing.
Okay.
We wrote an account earlier this spring,
Mhm.
and we had like 60 or 70 references, and even if you move things around, it reorganizes.
How many?
60 or 70
In the database or in the paper?
in the paper.
Okay. And how many are in the database?
I don't know, hundreds. You import your actual PDF into Mendeley, and it'll either look it up for you if it's there. Otherwise, it has a template where you just enter the information from the paper.
Good, good. It is an alternative, and probably this one is free source.
Yeah.
The end node is a little more. Okay, so done with standard things. Do you think you are the first person in the world history who read a paper? Oh yeah, discussion. You just argue until my results are right, and whoever argues with me is fool. But the question of communicating results, not necessarily scientific, not necessarily results, but communicating set of information from one brain to another brain is a standard task for humankind for centuries and even several millennia. Right? There were, and this question was raised in different cultures. So in this Greek, Roman, medieval culture, there were philosophers who were thinking and writing about how to write 3,000 to 4,000 years ago. And in the Greek culture, there was more philosophical recognition of what are the parts of building material that you actually invent. You decide how you present, how you deliver, and most important, how you arrange your already ready statements in the way that it is easier to digest. And in the next slide, I'm going to cover, this is only my reading from Wikipedia. My specialty and probably not your specialty, but you can be a little exposed to this ancient culture. So Roman culture was more practical, not general philosophy, but practical achievements of goals, like military skills and engineering, rather than general philosophy. So there are literal recipes how to arrange piece of like set of statements so they are delivered and presented and digested in the best way. So according to this ancient discussions, the reason of main presentation, and do not look at me, I'm not a good example, but general ideal presentation is written or oral is to entertain, to teach something new, and to urge audience to do something. Like in the didactic academic environment, probably to entertain, you have an idea what is entertain, teach, also an idea, information, and to urge to do something like my goal is to urge you to complete written reports. And if you present or if you write some homework, do not connect to discuss. Your goal is to urge grader to put your highest grade. So there is always a goal. And if it is a lawsuit trial, each side has their own goals that may contradict. So this Cicero, who is one of the champions in oral presentations in ancient Rome, left recommendations how to logically arrange information that you want to deliver. And this ancient arrangement of logical statements is a little bit different from what we do in technical writing in scientific things. You do not need to literally follow this more than 2,000 years late obsolete recommendations, but being aware of them may help you to glue together pieces. If you get stuck in writing and fluency and logical connection between pieces of your writing, it may give you additional momentum, additional inspiration to complete it. So what is mostly surprising, this always just taken from what was mostly surprising to myself is that if you walk through sections which are count of 6 rather than 4. Well, we can also tell that we are doing 6 if you count abstract and make discussion a separate section. But typically, if you do standard introduction, methods, results, and conclusions, we have 4, they have 6. So the actual we have scientific results, actual content is supposed to be like 10% of the overall presentation, which we cannot allow ourselves. If you are attending scientific conferences, reading scientific papers, or writing them yourself, you see that factual material takes like 90%. The rest is some of us consider the rest is just to mumble something who needs it and conclude to help audience to memorize you will. And just stick in as much as possible results, right? In whatever time you have. In this ancient documentations, it was only 10%. Most of the time or space on the paper was recommended to use for other purposes. So first, the exordium, which is ancient abstract, is to just launch audience and briefly tell what is the goal, what are we going to do to attract attention. Then the next one, which looks similar to English narrative, is to declare open problems, or declare what is not clear, why we sit together and what we are discussing. And next, to do the outline and just split problem into several little problems or aspects. Then the actual non-trivial part, the validation of the parts of materials that were introduced earlier, are in this proof of case and in writing contrary yourself. We're not trying to pronounce them. Sounds like, reads like English confirmation. And then there was a recommended section that is in some correspondence to discussion section, where author should think ahead how his or her arguments will be received by audience. The author should anticipate that not everyone among the readers or in the audience will be super happy. There will be some jerks who will be critically perceiving this information and start giving arguments against whatever results or whatever you present. And thinking ahead about these opportunities, author may design counter arguments to possible criticism. Think ahead. When you present something, someone will criticize you. If you are in the academic environment, if you are on some group meetings, you have seen. If you visited scientific conferences, you have seen such events. Right? The simplest thing when someone stands up and tell, like, okay, tell me why everything is wrong. Especially in theory, it is very typical approach. So think ahead of possible arguments and prepare to address them. And in the conclusions, I like most, so it is not my words, it is from Wikipedia. Cast anyone who disagrees in a negative way. And develop positive feelings to the author, client, and the oral case. Typically, we do not do it in scientific papers, maybe a little bit in proposals. But keep it in mind. Right? No. How did I get there? No. I just want to. Oh. It was an inverse review. This is what you were doing last time. Yes, it is what we discussed today, and it is my favorite slide. Okay, thanks much for your patience. It looks like I will not present anything to you for the rest of the course. Now it is your time to write, review, and present. Please don't hesitate to send me emails at any time of day and night. I will try to address this as quick as possible. And technical questions or questions about arrangements, try your best to complete written reports. And please bring 3 copies of your printed 3 copies of your written reports to the class on Tuesday. Why 3 copies? Yes, why?
Pass them around and review.
Yes, yes. So we will play into authors and reviewers. So written reports will be distributed among reviewers, and reviewers will write reports with recommendation of accepted is, declined because it is not science. Or reconsider after major revision. I don't know what to say else. I don't know about your feeling, but I'm very happy for you being part of this class, and I'm happy that it comes to hopefully successful conclusion. Meeting is done. We are going offline, and I'll stay here to answer questions if any.